All right, to begin this, I'm sure people haven't heard of this before. That's why I have to share it. Something called the Goldschmidt Classification. The Goldschmidt Classification, developed by Victor Goldschmidt, is a geochemical classification which groups the chemical elements according to the preferred host phases into lithophile, which is rock-loving, siderophile, iron-loving, calciphile, I think that's how you pronounce it, ore-loving or calcigen-loving, and atmophile, or gas-loving, or volatile, the element or a compound in which it occurs as liquid or gaseous at ambient surface conditions. As we'll learn here that it's much more complicated than that, but this is just a basic overview, beginning of what it means to have differentiation inside of a stellar body. And here we have the different elements highlighted. You'll pull this up on Wikipedia, you'll see this, but since it didn't come out in color on my printer, I had to go ahead and color it in for you. But basically you have lithophiles, which are the orange, all over here. And you have your siderophiles, which are the iron, cobalt, nickel, rhodium, osmium, iridium. Your calciphile, which are like copper, zinc, cadmium, selenium, lead, bismuth, those, and sulfurs over here even as well. And you have your atmophiles, which are, hydrogen, carbon, nitrogen, and noble gases. They're over here. And you have your synthetics, which, man-made. Doesn't really count. Basically, I want people to look over this, because look at all those elements. Okay. We have to include all elements if we're going to discuss how the Earth got to be the way it is. And we have to look at nature as being very, very, very complex. But before we do that, we have to break things down into things that are easier to understand. Establishment science, their accepted models for Uranus and Neptune are very, very poor. It's a very poor theory. They say, oh, well, it's just rock and iron in the center and metallic hydrogen and hydrogen, molecular hydrogen. This is horrible. This is very, very bad, because it means, well, where did the rest of the elemental table go? They just say, oh, it's rock and then hydrogen. Hello, what about all these? They don't even know what they're doing. They're idiots. In stellar metamorphosis, Neptune and Uranus actually have layers to them. And these layers are not purely differentiated by the Goldschmidt classification, but this is an overview of what it means. You have a siderophile, which are iron and nickel loving in the center. Obviously, this would be more pure iron nickel. This isn't to scale, though. This is just a demonstration of how these objects are layered. Atmophile elements would be on the outside. Calciphiles would be towards the center next to the siderophiles, and the lithophiles would be, the lithosphere. That's after lithosphere. These are the beginning elements that will create the crust when this material falls inwards. And obviously all this is ripped away as this object is, orbiting another host star. But to outright ignore all the elements, the reason why they do that, and I think I nailed it earlier, is that astronomers, they classify all elements that are heavier than hydrogen and helium as metals. They literally do that. I'm not even making this up, people. They think all the elements that are heavier than hydrogen and helium are metals. You know what that does? That means they ignore chemistry. Chemistry isn't important to these people. That's why they try to make everything as hydrogen and rock. You see how bad theory that is? That's horrible theory. They have no idea what they're doing. They're just making mathematical models and using computer simulations when we have at our disposal chemical understanding spanning over 300, 400 to 1,000 years, and they completely ignore all of it. That's what we need to do here. We need to apply chemistry to the differentiation process inside of these objects. These are new Earths. These are very evolved stars, and they're on their way to becoming ocean worlds and forming the Earth inside their interiors. Now, as to the layers, how thick these layers are, that's also up to interpretation. We actually need to send satellites there to measure the interiors of these. But for the most part, our satellites have just measured this little thin layer right here, and we believe that's all it is. But clearly, astronomers are missing something. We can tell because they just clump everything as hydrogen and rock and ignore all the other elements. But anyways, that's a beginning part. I have to read a whole lot more about this and do a whole lot more clarification of it as well. I forget. Also look up Markland Convection. Markland Convection is the process where in a concentric cylinder, the material sorts itself based off its ionization potential. Meaning the iron goes to the center with a nickel, and you have magnesium, and you have oxygen, hydrogen, helium on the top. So when the star is ionized and the material is very, very energetic, it sorts itself based off of its ionization potential, and it subsequently goes to cooler and cooler regions of the star as it cools. But that's very important too, as well as what chemicals combine with which, and that determines like where they will sort out from there. It's a very, very complex process. Planetary differentiation is, stellar evolution. But just clumping it all together as hydrogen and rock, that's that's insane. All right, today's March 16th, 2016.